AP Cram, Calculus AB, Free Response Exam Review. Question 16, Implicit Differentiation, Second Derivative. Consider the differential equation dy dx is equivalent to 2x minus y. Find d2y dx squared dx, or I'm not sure how you say this, I just know it's the second derivative, in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. If you expanded the x-axis towards the left, this would be quadrant 2, and give a reason for your answer. All right, so some of you might be like, huh, like what? Okay, just hold on a moment, but for those of you who know what's going on, gather your thoughts, press pause, and write down your answer. All right. Okay, let's get into this. In order to solve this, you need to use implicit differentiation. This has two hidden terms in it. So d2y dx, I'm going to say squared, is actually the derivative ddx of dy dx. Okay, so it's like a hidden derivative within here. That's why it's like the second derivative. So if you distribute d dx to the first term, 2x, you're going to get 2. And if you distribute d dx to y, you're going to get d dx of y, or just dy dx. But hold on, what is dy dx? dy dx is actually this whole thing. And that's the neat feature about differential equation, because you don't need to be a math genius. That is, good with numbers and division and multiplication, because most of these problems are just solving riddles, and the mathematics is actually basic. You have to be a better thinker than you are a mathematician, okay? So we know the value for this is 2x minus y, so that's what we're going to plug in here. Okay, so half the work is done. So 2 minus 2x minus y is going to become 2 minus 2x plus y. But the second portion of our question wants us to determine the concavity of all solution curves in quadrant 2. Well, we have to look at the x and y values in quadrant 2 to figure this out. So in quadrant 2, all the x values are positive, okay? But all the y values are positive, but all the x values are negative. So let's say you have a negative 1 here. That's going to give you a positive 2. And let's say you have a positive 1. That's going to give you a positive answer. And if there's a positive answer for the second derivative, or just the derivative, the concavity is going to be pointing upward. So in quadrant 2, because all x's are basically less than 0 and y's are greater than 0, this is going to make 2 minus 2x plus y greater than 0. And therefore, all solution curves are in quadrant 2, are facing concave up. Okay? All right.